Today I will introduce 4 new features of OneClick for plastic-based panels: slot lock on plastic panel, half joint, double end cutter, and subtract by intersection. First is a slot lock on plastic panel or the hook joint. For example, here you will create a hook joint between two panels. Simply select plastic lock and click the two panels you want to connect. Here's a simulation of the hook joint. The joint will be generated on the surface you click. For instance, if you click the bottom face, the bottom side will receive the joint. This helps minimize two-side machining. Now, let's go through the parameters of the hook joint. Connector range. The distance from the panel edge to the inner edge of the mortise on the female panel. As shown here, range 1 is 94, range 2 is 186. Here's a diagram for clarity. L is the hook length, L1 the joint length, and L2 is the joint depth. Extent length and tolerance are tolerance values applied to the mortise cut, making it easier to assemble the joint. If you want to reverse, check this option and recreate the link. To make the correct hook direction from back to front, in order to ensure the panels fit together correctly during assembly without errors, please add labels to the panels. Next is a half joint. Previously, OneClick only supported predefined half joint patterns from libraries. Now, it's allowed creating half joint for any two panels. Just select the function and the two panels. Done. Here, you can adjust the parameters as needed. Tool diameter and tool number depend on the actual router bit you are using. By default, OneClick positions the vertical one at the back. If you want it in front, just take this box and regenerate the joint. As you can see, the vertical part has now moved forward. Increase safe gap 1 to widen the mortise. Increase gap 2 to deepen the mortise cut, often used for corner clearing. There is also an option for cut using profile intersection. To explain this clearly, let's first look at the double end cutter feature. Normally, for plastic parts, the panel width equals the stop width, so operators only need to cut both ends without cutting the entire perimeters. To achieve this, we use double end cutter. For example, with this panel, select the tool, adjust parameters as needed. Tool diameter and number should match your actual tooling. Then click twice near the edge you want to cut. The first click shows a red line. The second click confirms it. The line turns black. Do the same on the opposite edge. Note, the black cut line must be on the same plane as the panel, and both black lines must be on the same surface. If they are on the different surfaces, machining will run on two sides. If you want to subtract the thickness of edge banding, enter the value here. Next, configure the post-processor for plastic. Go to Setting. In Post-Processor, select Plastic. In the Tool section, accurately enter the tool diameter. In the header and footer, set the Z0 position to machine bed. In the general parameters, tool path spacing should be slightly larger than the tool diameter. For example, with this tool, set the gap to 4. Keep the bin offset at 0. The board width should be set to 0.1 mm larger than the material thickness. This section requires the creation of labels for the details when generating the code to avoid any potential errors. Then, proceed with post-processor. In the G code, you will see two tool paths. Especially, this feature generates an additional custom tool part to cut off the ends. In this case, we can set the number of passes for the outer cut to 0 to disable the path, leaving only the custom cut active. When simulating in Simco, you will see that perimeter cut does not plunge. Only the two end cuts are executed. This keeps the side edges intact. Back to half joint with cut using profile intersection. If you only want to cut for half joint itself without a perimeter cut, take this option. And remember to set the number of passes for the outer cut to 0 before generating the code. The simple simulation will show only the half joint cut being executed. Finally, subtract by intersection. Suppose you have two intersecting members, and you need to notch one panel to fit a cross piece. Because the router bits have a radius, cutting this path leaves rounded corners. The operator would normally have to chisel or overcut the mortise to fit the cross member. OneClick now provides a corner relief hole option. When checked, the software automatically generates a diagonal toolpath to clear the corner radius right here. This eliminates the need for manual chiseling. If there are multiple overlapping panels, use the extra cut length option. For the outer panel, uncheck these two boxes and create the notch. For the second panel, recheck the boxes and enter the outer panel thickness, for example, 17. Click on the panel, and now you will have a toolpath cutting from the outer face through to this depth. These are the 4 new features for plastic panels in OneClick. Download link is in the description below.